Welcome to another Chapter 6 video. This one is dealing with percentiles in that normal distribution. Remember, percentile refers to a percentage of the data below a value. And in the normal distribution, if we're looking at something like the 92nd percentile, that would mean in our normal curve, whatever x value it is, that 92% of the data is down here, which is a probability of 0.9200. So whatever that x value is. And you can kind of think of this one as going backwards from those prior ones. General concept is you go from probability to a z-score to an x value. That's the step process for a percentile, where probability, we started with the x, made the sketch, went to the normal with the z, and then used the table to find the probability. This one's going sort of in the opposite direction. So, for an example, in order to be accepted into a university, you must score in the top 5% on the SAT exam. It has a mean of 1,000 and a standard deviation of 200. And this is normally distributed. It is a standardized test, so it has been normalized. So it is normal. It has a mean, which is given to us, and a standard deviation, which is given to us. The question asks for that top 5%. So in our curve, that 5%, that top 5%, which means that 95% is below it. We're looking for the 95th percentile. Which is a probability of a 0.9500. And when we're looking at these, we need to find the probabilities and corresponding z-scores. Our goal is a 0.9500. We may not find an exact value for that. In fact, most of the times we don't. We do know that our probability is more than 1/2, so a corresponding z-score down here would have to be positive. So if we go to our normal table, the part that we're looking for here is on the inside. The probability is what is given to us. And in particular, we're looking for a 9500. 95%. So as we're looking through there in the middle, you can read a 70, 77, etc. And you get as close as you can to 95. One below and one above we can observe. It's actually somewhere in the middle here, surrounded on either side. Now going back, we had a 0.9495, which was below it. That came with a z-score of 1.64. The other one came with a z-score of 1.65. So a 1.64 would give us 9495, and 9505 was the other value, and it came with a z-score of 1.65. The difference between these, 0.0005, and this one is also 0.005. The difference between the two probabilities. We typically use closest. In this case, they are the same this time, not always. So we're going to use a 1645, the exact middle, because this is the same distance. Sometimes you'll be asked to use the 1.65. Different textbooks will do a little bit different, and different scenarios you'll see different scores. We would use the 1.645 in your problem sets or the 1.65, either one of those. But what we were asked for is the actual score, which means that is an x value. And x is equal to mu plus z times sigma. It comes from solving the formula for a z-score. So our mu was 1,000. Our z-score is 1.645. And our standard deviation is 200. And I do want to point out parentheses, order of operations. That gives us a score of 1329. So that university would publicize that if you get a score of 1329 or greater, you will be accepted into the university. So that's finding percentiles using the normal distribution.